Howdy! In this video, we're going to find the derivative of y equals secant x times cosecant x. The key word there I said in the middle was times. Anything two functions or factors are multiplied and we're finding their derivative, we will also need to use the product rule as we go, as well as the derivative rules for secant and cosecant. So let's apply the product rule here. So product rule says that the derivative of this expression is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So first factor is secant of x times the derivative of cosecant of x, which is negative cosecant x cotangent x, plus the second factor, which is cosecant of x times the derivative of the first factor. The derivative of secant x is secant x times tangent x. That's really the derivative. The rest, and probably the harder part now, is just simplifying all of that, right? So let's pull the negative out. Let's see, we have a secant, a cosecant, and a cotangent. That's three different ratios. I bet we can simplify that. What I would do is recommend that since we have so many different ratios, I would put all of them in terms of sine and cosine, and then see what cancels. So secant x, we can rewrite as 1 over cosine of x, times cosecant of x, that's 1 over sine of x, times cotangent of x, that's cosine over sine of x. Okay, and then we have plus cosecant of x, again, is 1 over sine of x, times secant of x, that's 1 over cosine of x, times tangent of x, that is sine of x over cosine x. So when we multiply all these together, you can see that in this first fraction, we'll have a cosine divided by a cosine. So we'll have negative 1 over sine squared x plus, same thing over here, we've got sine divided by sine. So plus 1 over cosine squared x. So we could leave it like that. We could get a common denominator, or at this point, we could maybe, it's possible if we convert back into cosecant and secant, you might be able to use an identity, but I don't think so. So you could, and you could stop here. But I think what I'm going to do is get a common denominator real quick and see if I can make it simplify a little bit more. So I would need to multiply the first fraction by cosine squared of x over itself. So that'll give me negative cosine squared over sine squared x times cosine squared x plus 1 over cosine squared x. Actually, not 1 over. We're going to multiply that one by sine squared over sine squared. So let's put a sine squared x in both that numerator and denominator. And we could add them together. So on the numerator, we'll have negative cosine squared x plus sine squared x. I'm going to reverse that and just call it sine squared minus cosine squared all over sine squared times cosine squared. You could use a double angle identity to simplify the numerator if you wanted to. There's definitely a lot of different forms of the correct answer for the derivative here. So I think I'm going to stop there, though. That's one form of the correct answer. Alternately, you could take this line up here, right? 1 over sine squared, that's cosecant squared. So negative cosecant squared x plus secant squared x. There's another form of the correct answer. And again, you could go into double angle identities if you really wanted to. But either way, there's the derivative of secant x